Today, we're really grappling with something foundational for tech's future, AI alignment. We've got a great stack of sources here, especially looking at Brian Christian's book, The Alignment Problem. Our mission to cut through the noise. We want to understand why making sure AI systems work with human values, not just, competently, is so incredibly complex. Okay, so let's jump right in. The basic challenge as I see it is that an AI can be technically perfect, hit all its targets, but still fail, sometimes spectacularly, because the outcome isn't what we intended, or maybe it violates our ethics. That gap, that's misalignment, right?
Exactly. And what's really striking is how fast this went from maybe a thought experiment to a serious practical safety issue. The urgency is just immense. AI isn't just in labs anymore. It's out there making big calls in finance, healthcare, you name it. So if these systems are even slightly off, slightly misaligned on their goals, the consequences can scale up massively. We're talking potentially serious hazards.
Right. So if we boil it down, what are we actually aligning to? It's clearly more than just, telling a self-driving car to turn left.
Fundamentally, yeah, it's about safety, it's about ethics, trustworthiness.
Mm.
We need AI to reliably get the outcomes we humans actually value
Yeah.
and to operate within, well, our often messy ethical boundaries. The big difference now compared to the early AI days is how complex failure can be.
Yeah, thinking historically, failure used to be simpler, almost quaint. Like that chatbot Eliza in the 60s. It sounded humanish, but it didn't understand a thing, just followed a script.
Right, back then, misalignment was pretty surface level, a basic lack of understanding. Modern misalignment, it runs deeper. It's when a super complex algorithm follows its programming perfectly, but that programming accidentally encodes or even amplifies harmful real-world biases. The system does its job competently, technically, but the result is unethical, simply because of how its goal was defined or the data it learned from.
And this feeds right into why everyone feels this urgency now. These kinds of misalignments, they just chip away at public trust. When you think about AI showing up in everything from cars to policing, well, solving this alignment thing feels pretty fundamental to keeping things stable. Okay, this is where we need to talk about the real cost of getting it wrong. These aren't just theories. We're seeing actual harm in really critical areas. Let's start with healthcare. There was that case where an algorithm meant to help patients actually created unfair
Ah,
outcomes.
yes. That one's a really powerful example. It shows how algorithmic bias can just latch onto existing societal problems and make them worse. So the idea was algorithms would flag patients who needed extra care, extra resources. Sounds good, right?
Yeah.
But they were trained using historical healthcare spending data as a stand-in, a proxy for medical need.
Okay, wait, using spending as the metric. What was the flaw there? Why did that go wrong?
Well, the crucial takeaway is that AI systems get really good at optimizing for whatever metric you give them, even if that metric is, well, totally misaligned with the actual human value you care about. In this case, the value was equitable care. But because of long-standing inequalities in access, minority groups historically had less spent on their healthcare. Less access, less spending. So the AI, just optimizing based on past spending patterns, ended up recommending less extra care for Black patients compared to white patients, even when they had similar levels of actual health need. The system did exactly what it was trained to do, optimize based on dollars spent, but the action was discriminatory, fundamentally unethical.
That distinction is so critical, optimizing for the metric versus the value. Okay, let's apply that same thinking to the criminal justice system. We almost have to talk about the Compass algorithm here,
Yeah.
right? Used for predicting recidivism risk.
We really do. Compass became sort of the poster child for algorithmic bias in that field. The model learned from huge amounts of historical crime and justice data, but that data itself reflected decades of, well, biased policing, biased judicial outcomes.
So what was the specific failure? How did that biased data lead Compass astray?
Essentially, the system got very good at spotting patterns linked to historical policing practices, not necessarily objective future crime risk. Who got arrested more historically, where were police deployed most, and the result. The algorithm disproportionately flagged people of color as higher risk for reoffending, even when you compared them to white individuals with similar backgrounds or actual criminal histories. The misalignment wasn't some random glitch. The data basically taught the AI to project past inequalities into future predictions. It ended up reinforcing racial bias, making the system inherently unjust.
Wow. And if we need proof that misalignment isn't just about social bias, but can cause pure chaos, we shift gears to finance and the 2010 flash crash. Speed and complexity took over there.
Oh, absolutely. That was a textbook case of algorithms doing exactly what they were told, but operating way outside human understanding or control. You had these algorithmic trading systems designed to make money off tiny price differences in microseconds, lightning fast. But they started interacting with each other in ways nobody predicted. It cascaded.
So the technical route was just algorithms feeding off each other, creating this kind of runaway feedback loop of selling that nobody could stop.
Precisely. Humans couldn't even track it, let alone intervene. It was too fast. In just a few minutes, almost $1 trillion in market value just vanished. Then, weirdly, it mostly recovered almost as fast. But the crash was a stark warning. It showed how unstable things can get when these complex, high-speed algorithms run without proper checks, without alignment towards overall market stability, and definitely without effective human oversight.
Okay, so we've seen the what misalignment and the impact, which can be pretty devastating. Now let's dig into the why. You're saying misalignment is tangled up in the tech itself, the data, the algorithms, but also the limits of us humans trying to watch over it.
Yeah, the power of modern algorithms is definitely a double-edged sword. Like we discussed, they learn from data. And if that data is bad quality, or if it's soaked in existing societal biases, well, you've basically built that bias right into the AI's foundation. It's structural.
And the really worrying part is how that flaw can then just repeat itself, right? Especially in things like predictive policing.
Exactly. It creates a feedback loop.
Mm-hmm.
The algorithm is trained on old data showing where arrests happened, often reflecting where police were sent, not necessarily where most crime objectively occurred. So AI learns that pattern, maybe suggests sending more police to those same areas, which leads to more arrests there, which generates more data, reinforcing the original pattern. It ends up amplifying the initial bias. It's not analyzing crime objectively. It's analyzing and often reinforcing historical deployment choices.
But isn't there another layer of difficulty? Even if we magically had perfect, unbiased data with these advanced deep learning models, these neural networks, don't we often run into the problem that we just can't follow the AI's reasoning? We hit that black box issue.
That's the opacity challenge, and it's huge. Modern AI, especially deep learning, often functions like a black box. Gives you an output, a decision, but tracing how it got there is incredibly difficult, sometimes impossible for us humans. And if you can't peek inside that box, how do you audit its logic? How do you spot subtle biases creeping in? How do you intervene effectively if you suspect it's going off the rails? It makes oversight incredibly hard.
Plus, we can't ignore the human factor in that oversight loop. The people tasked with monitoring these systems, well, we bring our own biases, don't we? Our own subjective views, maybe flawed judgments.
Absolutely. That human variability adds another layer of complexity to the alignment problem. You need training, sure, to try and mitigate those human biases and ensure oversight is consistent. But it's a constant challenge. We're trying to align these incredibly complex systems while dealing with our own inherent human imperfections. So tackling this, it's not just a coding problem. It really demands everyone getting involved. We need technical breakthroughs, yes, but also much smarter human processes and definitely strong governance frameworks.
Okay, let's spend a bit on the tech side first. There's some really fascinating research happening there. You mentioned inverse reinforcement learning, IRL. That sounds almost like AI trying to read our minds, figuring out what we really want.
Well, that's kind of the ambition, yeah.
Mhm.
Instead of us trying to explicitly write down a reward function, which, as we saw with the healthcare example, can go badly wrong if we pick the wrong proxy,
Yeah.
IRL tries to flip it. The AI observes human behavior, watches what we do, and then tries to infer the underlying values or preferences that must have driven those actions. It's essentially trying to reverse engineer our ethics by watching us.
Okay, but what's the catch? I mean, inferring intent from actual human behavior. We're messy, inconsistent creatures, right? That sounds incredibly difficult.
Oh, it is. That's the core difficulty. Humans aren't perfectly rational optimizers. We make mistakes. We do things that contradict our stated beliefs. Our behavior is noisy. So the challenge for IRL is sifting through all that noise, all that inconsistency, to figure out a reward function that reflects what we genuinely value deep down, not just what we happen to do in one particular instance, maybe under stress or when we weren't thinking clearly.
And then to tackle that black box problem we talked about, there's explainable AI, or XAI. Can you give us a simple way to grasp XAI, beyond just saying it makes AI understandable?
Sure. Think of XAI tools like maybe like mandatory translators or court reporters for the AI. They might not reveal every single internal calculation. The systems are often too complex for that. But they're designed to highlight the key reasons behind a specific decision. So for instance, in a medical diagnosis, AI and XAI component might say, diagnosis X was reached primarily because of symptom A, lab result B, and patient history factor C. That kind of explanation dramatically boosts accountability and trust. Human experts can then look at that reasoning and say, okay, that makes sense, or wait, why did it weigh factor B so heavily? even if the core algorithm remains a bit of a black box.
Okay, shifting to governance. Having strong policies seems absolutely crucial. The EU's AI Act is getting a lot of attention. It takes this tiered, risk-based approach. What makes that particularly relevant for alignment?
Their approach is significant because it directly links regulatory scrutiny to the potential harm an AI system could cause. Applications they classify as high risk, think critical infrastructure, healthcare decisions, law enforcement tools face much stricter rules. Mandatory audits of data quality, transparency reports, robust oversight mechanisms. It forces developers to think about alignment and safety right from the very beginning, from the design stage, not just as an afterthought.
But here's the classic challenge with governing tech, isn't it? By the time the laws are written and passed, the technology itself might have already jumped way ahead. Policy always seems to be playing catch-up.
That's absolutely a huge issue. The legislative cycle is slow, methodical. AI development is, well, often exponential. And layered on top of that is the need for global cooperation. AI doesn't care about national borders. If one country has really strict alignment standards and another is lax, companies might just develop or deploy risky systems in the less regulated place. It undermines safety everywhere. That's why international efforts in developing shared ethical standards like the SLMR AI principles or the IE's ethically aligned design framework are so vital. They provide that common ground, that external ethical guidance.
So the final piece of this puzzle seems to be making sure humans stay effectively in the loop. We can't just have people manually watching blinking lights on complex systems, right?
No, definitely not. Effective oversight has to be smarter. It probably means using other AI tools to help the human monitors. Think AI-driven systems designed specifically to watch the main AI, flagging potential anomalies, weird outputs, or signs of drift that need immediate human review. It's about making human attention more targeted, more scalable.
And crucially, building in really robust feedback mechanisms seems key. Ways to feed human insights, corrections, maybe even evolving ethical judgments back into the AI's learning process.
Exactly. So the systems aren't static, but can adapt and learn from ongoing human guidance and real-world experience. Ultimately, it really points towards a more collaborative design approach from the very start. You need the engineers, yes, but you also need ethicists, psychologists, experts in the specific field the AI will work in, even the end users, all at the table from day one. Alignment needs to be baked in from the beginning, not just bolted on later when something goes wrong.
When you put it all together, it feels like successfully tackling alignment isn't just about preventing disaster. It's actually about unlocking the real promise of AI, doesn't it? Moving beyond just damage control to creating systems we can genuinely trust that are reliable and actually make things profoundly better.
I think that's exactly right. If we get alignment right, imagine AI leading to truly fair, unbiased decisions in the justice system. Imagine it helping stabilize financial markets, preventing those flash crashes, or ensuring healthcare is delivered optimally and equitably to everyone who needs it. It could bring stability to complex global systems, maybe help us optimize solutions for really huge challenges.
What really stands out, though, is that this journey towards alignment, it's clearly not just a technical fix. It's not just about preventing harm. It feels like a much deeper, more fundamental challenge. It demands constant work across so many fields. Computer science, sure, but also ethics, law, sociology. It's truly interdisciplinary. So here's something to think about. If we could actually succeed, if we could align AI with human values globally, what's the single biggest, currently unsolvable societal problem you'd hope we could entrust to an aligned AI system first? Definitely something to keep mulling over as we all navigate this incredible and slightly terrifying technological wave.